Namaste and welcome back to JEE Chemistry with Typical Monk. This is Class 19, the P block, Group 15, the nitrogen family. Group 15 opens with nitrogen, locked in a triple bond so strong that the gas floats through our air almost untouched. Yet, once freed, it becomes ammonia, nitric acid, and the fertilizer that feeds the world. Below it sits phosphorus, glowing and restless in its strained tetrahedra. Today, the nitrogen family, Haber, Ostwald, the allotropes, and the oxoacids that trap every student, one idea at a time. Here is what you will learn today. First, the group 15 trends and anomalous nitrogen. Second, dinitrogen and ammonia, the Haber process. Third, nitric acid, the Ostwald process, and the oxides of nitrogen. Fourth, phosphorus, its allotropes, phosphine, and phosphorus trichloride and pentachloride. And fifth, the oxoacids of phosphorus and their basicity. One idea at a time. 4 ideas. Run this entire chapter. Look at them together first. Group 15. Nitrogen, phosphorus, arsenic, and below 5 valence electrons, and oxidation states running from -3 to +5. Anomalous nitrogen. Small, with no d orbitals, it forms strong p-pi multiple bonds, giving the nitrogen triple bond, and its maximum covalency is only 4. The trends down the group. Metallic character rises, the +5 state grows less stable, and the +3 more stable through the inert pair effect. And catenation and allotropy. Phosphorus catenates and shows several allotropes. Nitrogen does neither. Now look at the picture. The two faces of phosphorus, white against red. White phosphorus. It is built of discrete P4 tetrahedra. The 60-degree bond angles leave it badly strained, and so very reactive. It is toxic, and it glows in the dark. Red phosphorus. It is a polymeric chain of linked P4 units. It is far less reactive, and it is non-poisonous. Black phosphorus, the most stable allotrope of all. A layered, sheet-like form. And why the difference? The strain locked inside the P4 tetrahedron makes white phosphorus reactive. The polymer relieves that strain, and so red is calm. Now from inert nitrogen to nitric acid. The ribbon holds the root. Nitrogen and hydrogen by the Haber process to ammonia, then ammonia by the Ostwald process to nitric acid. Dinitrogen. It is very inert because of the strong nitrogen triple bond, and that bond is the great bottleneck of nitrogen fixation. Ammonia. It is made by the Haber process. Dinitrogen plus 3 hydrogen gives 2 ammonia over an iron catalyst at high pressure, and the molecule is a pyramidal Lewis base. Nitric acid. It is made by the Ostwald process. Ammonia is oxidized to nitric oxide, then to nitrogen dioxide, and then absorbed in water. And the oxides of nitrogen. Nitrous oxide, nitric oxide, nitrogen trioxide, nitrogen dioxide, and dinitrogen pentoxide, nitrogen in every state from +1 to +5. Let us work the G favorite, the basicity trap. What is the basicity of phosphoric acid, phosphorus acid, and hypophosphorus acid? The rule. The basicity of an oxoacid equals the number of POH groups it has. A hydrogen bonded straight to the phosphorus is not acidic. Phosphoric acid, H3PO4. All 3 of its hydrogens sit on OH groups, so it is tribasic. Phosphorus acid, H3PO3. It has 2 POH groups and 1 pH bond, so it is the basic, not tribasic. Hypophosphorus acid, H3PO2. It has 1 POH group and 2 pH bonds, so it is monobasic. The lesson? Count the POH groups, never the total hydrogens. Those pH bonds are the whole trap. Now the picture that fixes it all. The oxoacids of phosphorus, where the structure decides the basicity. Phosphoric acid, H3PO4, 1 phosphorus oxygen double bond, and 3 POH groups, all 3 protons ionize, so it is tribasic. Phosphorus acid, H3PO3, 1 double bond, 2 POH groups, and 1 pH bond, only the 2 protons on the hydroxys ionize, so it is dibasic. Hypophosphorus acid, H3PO2, 1 double bond, 1 POH group, and 2 pH bonds, only that one ionizes, so it is monobasic. And the count. Basicity is simply the number of POH groups. The pH bonds never ionize. Now what JEE actually asks. 5 pointers. 1. Anomalous nitrogen, no d orbitals, pp bonding gives the nitrogen triple bond, a maximum covalency of 4, and dinitrogen is chemically inert. 2. The Haber process, nitrogen plus 3 hydrogen to 2 ammonia over iron, and the Ostwald process, which makes nitric acid from ammonia. 3. White phosphorus is reactive P4 tetrahedra. Red phosphorus is polymeric and stable. 4. Phosphorus trichloride is pyramidal, sp3. Phosphorus pentachloride is trigonobipyramidal, sp3d, with unequal axial and equatorial bonds. And 5. Oxoacid basicity is the number of POH groups. Phosphoric acid tribasic, phosphorus dibasic, hyperphosphorus monobasic. Now an assertion and reason drill. For each pair are both true, and does the reason explain the assertion? First pair. Assertion: dinitrogen is chemically inert at room temperature. Reason: it has a strong nitrogen triple bond with a very high bond dissociation energy. Both are true, and the reason directly explains the assertion. That strong bond is precisely why it is inert. The answer is A. Second pair. Assertion: phosphorus acid, H3PO3, is a tribasic acid. Reason: it has 3 hydrogen atoms in its formula. The reason is true, but the assertion is false. One of those hydrogens is a pH bond, which does not ionize, so the acid is only dibasic. The answer is D. Third pair. Assertion: white phosphorus is more reactive than red phosphorus. Reason: phosphorus exhibits allotropy. Both are true, but the reactivity is due to the strained P4 tetrahedron, not merely to the fact that phosphorus has allotropes. So the reason does not explain the assertion. The answer is B. Now match each term to its fact. The Haber process goes to ammonia. The Ostwald process goes to nitric acid. White phosphorus goes to the P4 tetrahedron. And phosphorus acid, H3PO3, goes to dibasic. 4 pairs, each worth committing to memory. Now, how many of these 3 statements are correct? 1. Dinitrogen has a triple bond, which makes it inert. That is correct. 2. Phosphorus acid, H3PO3, is a tribasic acid. That is wrong. It is dibasic. 3. White phosphorus consists of P4 tetrahedra. That is correct. So the answer 2 are correct, statements 1 and 3. The trapper statement 2, phosphorus acid is dibasic since one of its hydrogens is a pH. Now the 2 mistakes that quietly cost marks. The myth: the basicity of an oxoacid equals its number of hydrogen atoms. The truth: basicity is the number of POH groups. A pH bond does not ionize. So phosphorus acid is dibasic, and hyperphosphorus acid is monobasic. The second myth: nitrogen forms pentahalides, like phosphorus pentachloride. So nitrogen pentachloride exists. The truth: nitrogen has no d orbitals, so its maximum covalency is 4. Nitrogen pentachloride does not exist, though phosphorus pentachloride does. Now, test yourself. Answer in your head before the reveal. That is how JEE speed is built. Here we go. Question 1. The basicity of phosphoric acid, H3PO4. Tribasic. Question 2. The basicity of phosphorus acid, H3PO3. Dibasic. Question 3. The process that makes ammonia? The Haber process? Question 4. The shape of phosphorus pentachloride? Trigonal bipyramidal. And question 5. The unit of white phosphorus? The P4 tetrahedron. Let us gather it all in one breath. Group 15, nitrogen to bismuth, anomalous nitrogen with no d orbitals, the nitrogen triple bond, and a covalency of 4. The Haber process makes ammonia, the Ostwald process makes nitric acid, and the oxides run from nitrous oxide to dinitrogen pentoxide. White phosphorus is P4 tetrahedra, reactive, Red phosphorus is polymeric, stable. Phosphorus trichloride is pyramidal. Phosphorus pentachloride is trigonal bipyramidal, sp3d. And oxoacid basicity is the pOH count. Phosphoric 3, phosphorus 2, hypophosphorus 1. Next class, the P block, group 16, the oxygen family. From the unbreakable triple bond of nitrogen to the restless tetrahedra of phosphorus. Group 15 rewards the student who reads structure, the Haber and Ostwald roots, the allotropes, and the pOH count that fixes every basicity. Sarah, David, Lisa, and John all began exactly where you are sitting now. One idea at a time. You will crack JEE. I will see you in the next class.